Hello everyone. Today's presentation is focused on modeling in information retrieval. Information retrieval is essential for extracting relevant documents or data from large collection based on a user's input. By understanding various methods and models, we can appreciate how IR systems actually process queries and deliver results that are both relevant and timely. Let's explore the taxonomy of models, their formal characteristics, and how they contribute to efficient information retrieval. To better understand the structure of IR systems, it is relevant and helpful to look at the taxonomy of IR models retrieval in IR that can be broadly classified. The user task is mainly either browsing, which can be the flat, structure guided, or hypertext, or it can be of retrieval search routing. Now, for retrieval search routing, we have two basic models: a classic model, which includes the Boolean model, the vector model, and the probabilistic model, or the structured models, which include non overlapping list, proximal nodes. In the classic models, we have further classification into set theoretic, algebraic, and probabilistic. In set theoretic, we have the fuzzy and extended Boolean models, while in the algebraic, we have the generalized vector, latent semantic index, and neural networks. In the probabilistic models, we have the inference network and belief network. All this will be discussed in deep in the ahead slides. Now, in retrieval, specifically through search and routing, is the process of finding relevant documents or information based on a user's query. For this, we have ad hoc and routing. Ad hoc is also known as searching. This involves a relatively static document collection where users submit queries to find relevant data, similar to how library systems operate. Users input keywords or phrases, prompting the system to search through the collection. For example, think of searching for machine learning tutorials on a search engine. The document collection is mostly static and the query is new each time. Routing is also known as filtering. Here, user queries remain constant while new documents are continuously added to the system. The system dynamically matches new documents to the queries, ranking them based on user profiles and preferences. Unlike filtering, where results are not ranked, routing helps prioritize documents by relevance. An example of filtering is a news app that updates articles throughout the day based on the user set preferences. The system continuously routes new articles to the users who have chosen relevant topics. These approaches are foundational to how modern IR systems handle different data retrieval needs. Next, we'll talk about browsing in information retrieval. Browsing is a user driven method of information exploration where users navigate through information without a specific query. IR also supports browsing where users explore information without specific queries. The user driven methods allows navigation through information structured in various ways. Following are the structures which we will discuss in detail: flat, structure guided, and hypertext. Flat structures present documents in a flat structure without any hierarchical organization, making it straightforward but less organized. Structure guided browsing organizes content in a hierarchical manner, aiding users in navigating systematically. And hypertext navigation uses interconnected nodes or pages, enabling a web like browsing experience common on many websites. Browsing enhances discovery and is particularly valuable in digital libraries and comprehensive websites. Next, we'll discuss the classic information retrieval models. Now, let's delve deep into the classic IR models which were mentioned earlier. The first one, Boolean, which is a subset of the classic models. This model uses logical and or not to retrieve documents that match query terms exactly. It's straightforward but lacks flexibility for partial matches. Next, we have the vector space model under the classic models. Documents and queries are represented as vectors in a multi-dimensional space. Similarity is measured by the angle or distance between the vectors. Smaller the angles imply higher the relevance. Last but not least, under the classic models is the probabilistic model. This model assigns a probability that a document is relevant to a query based on the term occurrences and other statistical factors, ranking results accordingly. These models have laid the groundwork for more complex IR techniques. Now, we'll discuss the advanced IR models. Building on the classic models, we have more nuanced approaches. The first is the set theoretic models. An example is the fuzzy model, which extends Boolean logic by adding partial matches. This handles the uncertainty of query document alignment more effectively. For example, if you are searching for affordable housing, it may return documents that partially match with terms like low cost housing or budget homes. Next, we have the generalized vector algebraic models. One type is the generalized vector model, which modifies the original vector space concept by introducing alternative similarity measures to refine results. An example of this can be a refined search algorithm in a research database might use cosine similarity variations to rank papers more accurately. These advanced models address limitations found in earlier approaches, enhancing how IR systems match complex queries. Now, we'll talk about the formal characterization of Boolean models. Let's take a closer look at the formal definition of the Boolean model. An IR model can be represented as a quadruple of D, Q, F, R, Qi, Dj, where D is a set of logical representation for the documents in the collection, Q a set of logical representations for user information, needs or queries, F a framework that models the relationship between document representations, queries, and their interactions. R Qi, a ranking function that assigns a real number to a query Qi that is an element of Q and a document Dj that is an element of D, defining the relevance of ordering among documents for that specific query. This formalization helps us understand how documents are processed and matched with user queries based on logical relationships. A Boolean model application that I would like to share is searching science or technology and innovation returns documents that match the logical condition, such as articles mentioning science or technology and innovation together. Next, we have the slide discussing index terms, which is a set of all index terms in the system where T is the total number of terms and each Ki is a specific index term. Weights. Each document Dj has a weight Wi, j associated with each index term Ki. If Ki does not appear in Dj, then Wi, j is equal to 0. Document representation. Each document Dj is represented by a term vector. Dj is equal to W1, j, W2, j up until Wt, j, where each component Wi, j is the weight of the term Ki in Dj. Weight function, denoted as G, returns the weight of each term within the document's vector, facilitating the computation of relevance. The concept of mutual independence of keywords further simplifies ranking calculations, enabling faster IR operations. And finally, we talk about mutual independence assumption. The assumption of mutual independence among keywords simplifies fast ranking computations in information retrieval tasks. An example of documentation representation is a research paper about machine learning algorithms might have high weights for terms like algorithm, learning, and model, but zero weight for unrelated terms like weather or food. Finally, in summary, information retrieval modeling encompasses a range of models and approaches from classic Boolean and vector space model to advanced set theoretic and algebraic models. These models provide the structure for how IR systems interpret and match user queries with relevant documents. Understanding the formal characteristics and underlying mathematics of these models help us appreciate the complexity and power of IR systems in navigating and organizing vast amounts of data. Thank you for your attention, and if you have any doubts or queries, list them in the comment box or you can just ask Supriya ma'am. Thank you. Like, share, and subscribe.